All right. Doing work is a way of transferring energy. So, you can do work and you can store up potential energy. You can do work and you can cause a change in kinetic energy. And so this is this nice whale problem because whales are nice and big. So it's a 1.5 times 10 to the 5th kilogram whale. That's a big whale. Swimming with a speed of 6.1 meters per second. It speeds up to 12.8 meters per second. The question is, how much work does the water do on the whale? And this is kind of on purpose, you can tell. Because it doesn't make any sense, how is the water doing any work? Lazy whale, what's the whale doing with the water? Anyways, the idea is the whale's pushing against the water, and the water is pushing back against the whale. And that's actually what propels the whale in the direction that he's going. And so it's actually the work of the water on the whale that's giving him this extra energy. The only problem is he's got to push back on the water. Okay, so here we go. The work is equal to the initial kinetic energy. The final kinetic energy minus the initial kinetic energy. And once we figure this out, we can find out how much work that water did on the whale. And so the final kinetic energy is 1/2 times the mass of the whale, which is 1.5 times 10 to the 5th kilograms, times his velocity squared at the end of the whole thing, so 12.8 squared. And then we're going to subtract the initial kinetic energy, which is 1/2, 1.5 times 10 to the 5th kilograms times 6.1 meters per second, and that whole thing is squared. Look at this. I can make this way simpler by factoring out the m's. 1.5 times 10 to the 5th kilogram. So I'm going to factor that out because I might be lazy in a future lifetime. There we go. So now I'm going to get my calculator and I'm going to rely on you, the audience, to make sure that I don't do this wrong. So 0.00, almost made a fatal error there. 0.5 times 1.5 to the 5th times bracket 12.8 squared minus 6.1 squared bracket equals, wow, this is a lot of work. The water's doing a lot of work on this super lazy whale. It's like 9.5 times 10 to the 6th joules. And so the water has pushed forward on the whale as the whale pushes backwards on the water. It's counterintuitive as that seems. And we've given the whale more kinetic energy. Look at him go. And that had to be equal to the work that was done by the water.